Hello everyone. Today, this moment, I want to share you regarding the problem solving in superposition wave. This is coming from books Physics course book second edition from CUP. You can see on the page two. Oh yeah, 219. So directly we go to first number. This is actually in end of chapter question. Okay, number one, figure 15.19 show the stationary wave on the string. This is vibrator and this is wave around 1.5 wave. Question A, on a copy feature 15.19 label node and antinode. Okay, this is about node antinode. If we copy this here, number one, we have 1.5 wave. Yes, 1.5 wave. Yeah, this is node and node and node. We have 4 node and we have antinode here, 1 2 3, and we have 3 antinodes. Okay, question B, mark on your diagram the wavelength of the standing wave on the label as lambda. Yes, if only mark, this is lambda, one wavelength. So question C, the frequency of vibrators is doubled. Describe the change in standing wave pattern. Frequency double, it's mean total, the frequency mean total amount of wave on the time. Yeah, so if double, it's meant to like we are still on the one length, so we have if we said 1.5 wave, so we have 3 wave, 1 2 3, like this one. Okay, we have n equals to 3 here, 3 wave on that time. Okay, so continue to number 2. A tuning fork which produces note of 259 Hz is placed above tube which nearly filled water. The water level is lowered until resonance is per first heard. Explain what it's meant by the term resonance. Okay, the resonance, if we have a air column, an air column is has same like twister, yeah. And this is the first frequency, the second frequency, the third frequency, and so on and so on. Then the length of column air above the water when resonance first heard is 31.2 centimeter. Calculate the speed of the waves to sound wave. Okay, the first heard is, this is for frequency resonance 31.2. This 31.2 centimeter. So this is actually 1/4 lambda, yeah. So we get 1/4 lambda equals to 31.2. So lambda equals to 31.2 times 4. So we get 12 the calculator first. Oops. 31.2 times 4, this is equals to 12.124.8 centimeter. Yes, this is the wavelength. So if we change into other unit in meter, this is equal to 1248 meter. Yeah, so if we calculate about V is lambda of f, so lambda equals 1.248 times with frequency is 259. So if we calculate this, times with 256, yes, 319.48 hertz. Yes, this is the frequency, and this is the speed meter per second. Okay, so continue number 3. Yes, state two similarity to difference between progressive wave and stationary wave. Yeah, the two similarities, this is for progressive wave, they have same amplitude. Yeah, and they have same frequency. This is two similarities and two differences, yeah, between progressive and stationary wave. For the first is differences is they have a reflective wave, and they have superposition equation, like this one equals to y1 plus y2. Yeah. So if we know about the progression, only the progression wave, one wave, but on the superposition they have progression and then after that reflected. Yes, then this is differences between progressive and stationary wave. So for B, figure 15.22 show experiment measure of sound of string. The frequency of vibrator, understanding to figure 1522, is formed. Okay, they have 75 centimeter, and this is poly, this is vibrator, and there is loaded meshes. Question I, on a copy the diagram mark a note label N, anti-note label anti-note. Yeah, so if we draw it again, this is actually 1, 2, 3 wavelength. Yeah, 1, 2, 3, 1, 2, 3 here. Yes, here is node, yeah, node, this is node, this is node, this is node, and this is node, and this is antinode, this is antinode, this is antinode, and this is antinode, this is antinode also, this is antinode also. So we have a node 1, 2, 3, 4, 5, 6, 7 nodes, and 1, 2, 3, 4, 5, 6 antinode. Okay, so the frequency of vibrator 120 Hz. Calculate the speed at which a progressive wave would travel along. Okay, from the diagram, we have the length of this wave 75 centimeter. So it means 75 centimeter equals to 3 lambda. So we get lambda 25 centimeter. Yeah, or this is around 0.25 meter. So if the frequency of vibrator is 120 hertz, so we have V equals to lambda F 0.25 times, so around 30 meter second. Yes, this is the velocity of this wave. So the experiment is now repeated with the load on the string half. In order to get similar standing wave, the frequency has to be decreased to 30 Hz. Expand in the speed of wave in the string, wave frequency must be adjusted. So if the frequency now decreases into 30 Hz, so because the velocity has formula V lambda F, then lambda is constant 0.25, so we have the velocity is 125 times 30, so we get around 7.5 meter second. The velocity will be decreases than before. Okay, continue to fourth number 4. Yes, figure 1522 shows standing wave of frequency 400 Hz produced the speaker in the closed tube. Yeah, for and the tube. Okay, describe the movement of the air particle at A and B. The movement of the particle A and B, this is A, it's meant as the destructive point, yes, and B is constructive point. This is destructive and this is the constructive point. So when the piston on the point A, there is no hearing the frequency resonance here, but in B is maximum frequency. Okay, question B. The piston is slowly moved outward. The next resonance peak is heard when the length of the air column of air is 99.4. So the next frequency, it's mean this is around 1/4 or 5.4 lambda equals to 99.4 centimeter. So we get lambda 99.4 times 4 divided by 5. If we calculate this, times 4 divided by 5, it's equals to 7952 centimeter or 0.7952 meter. So if we calculate the speed of sound, the speed of sound is lambda F. Lambda we have 0.7952 times frequency is 400. So we'll calculate with, so we get 1.808 meter second minus 1. Yes, this is speed of sound. So the end correction must be what to say. Okay, thank you very much for watching my video. Don't forget to subscribe, like, and comment. Bye bye. See you in the next video.